Right, today we're going to learn about the law of conservation of mass, or sometimes it's called the law of conservation of matter. And what we're going to do is investigate, can matter be created or destroyed? A lot of times you see things like explosions, like the atomic bomb during World War II, or fire, and you're like, of course matter can be destroyed. But actually you might be surprised by the answer. So the first thing we're going to do is a experiment, if you will, and it involves 50 milliliters of water, an Alka-Seltzer tablet, which is usually what you take for colds, all right, which I have right now, so that would work real well. We're going to need a scale and a baggie. So the first thing I want to do is pour the water in the baggie. I'm going to seal that up real nice, I think. All right, and I'm going to put that on the scale along with the Alka-Seltzer tablet. And it says that it is 56 grams. So keep that in the back of your head, 56 grams. And what we're going to do is we're going to put the Alka-Seltzer tablet in the water, and it's going to dissolve. It's going to fizz and do all kinds of fun stuff. We have to make sure that the bag is completely sealed once we drop it in. And when it's done, we're going to weigh it again. We're going to see, is matter created or destroyed? Does it lose mass? Does it gain mass? Does it stay the same? Right now in your head, I'd like you to make a prediction. Do you think that it's going to go up or down? So it was 56 grams. All right, so here we go. Bag of water. Got my Alka-Seltzer tablet. I'm not going to let them in yet until I have it good and sealed. Okay. And I'm going to drop it in. All right. So it's fizzing, as you can see. You may be able to hear it. So when we get done, we're going to weigh it again on the scale. The thing about matter, so we're talking about the law of conservation of matter, is matter has to have three things. It has to take up space. Okay, it's clear that I take up space, that Alka-Seltzer takes up space, the air actually takes up space. It has to have mass. So when we think of mass on Earth, we think of weight. Mass is a little different when you get out into space because of the no gravity thing. But mass has basically particles in it, and then they create weight. And then matter is basically everything. It's everything around. There's a few things that we might talk about later that you question whether they're matter or not, and we'll have that discussion in class. But for now, I think our Alka-Seltzer is dissolved in the water. Okay, and I'm going to wait. You'll have to trust my numbers here. And it's the same as it was before. So this proves that in this situation, matter is not created or destroyed. We had a solid, when we talked about solids, they have a definite shape and they don't change whether they're in any certain type of container. So we had a solid, we added it to a liquid, and what we created was no more solid. What happened to the solid? Turned into a gas. That's why all the fizzing. So because we have the Ziploc bag closed, we don't let any of that gas out. And the bag actually kind of inflated a little bit because of that gas. So we're able to weigh the gas that was created because we kept the bag sealed. So again, matter cannot be created or destroyed, even in the situation of a bomb. Now, it might be changed into something new, though. And if we're able to contain all of the things that exploded and caught on fire and all of the gases that escaped from a bomb or from a fire, then you would see that it is the same amount of mass. It's really hard to do with that situation, but it's true. I promise you. Another good example is Legos. So if I have 2 blue Legos and 3 white Legos, okay, and I put them together, and now I have this, it's the same amount of mass. It's just that they're arranged differently. Okay, so I could put them even like this, and they'd be the same amount of mass as these ones that are not contained or not connected in my hand. Another good example is if you bake a cake. You put all the ingredients in, you put the eggs in, you put if you're just doing a cake mix, you use the cake mix, you put the oil, put the water, you mix it all up. If you were to weigh it in the pan and then put it in the oven, if there's a way you contain all of the gases that kind of escaped from the cake while it was rising in the oven, and you weighed the cake again after you baked it, it should be the same, because law of mass the law of conservation of matter says that matter cannot be created or destroyed. Another example would be if I took a piece of paper. Okay. This piece of paper, if I weighed it, I don't even know that it would weigh anything at all. It doesn't come up as a weight at all. So, but I can prove to you that this would weigh the same thing because of the law of conservation of matter if I tore it up into pieces. It's still paper. It's still the same amount of paper. It's still the same mass. It's just changed. So keep that in mind. Matter can't be created or destroyed, but it can be changed. So on our pretest, I asked the question that if you put an ice cube in a bag and you let it melt, if you weighed it before it melted and after it melted, remember, it would be the same because matter cannot be created or destroyed. All right. I can't think of any other great definition or examples right now, so I'll leave maybe that to you to be thinking about. And if you have any questions, please let me know. Your next step is to go into the next slide and answer the questions about our investigation.